Alright guys, this is the video for the 11 different ways to factor. Excuse me. And I don't know if this is the order I did it in class, but it really doesn't matter. It just shows you all the different ways. So first I'm going to do when a equals to 1. So let's do x squared minus 5x plus 6. As you see here, a is 1. When this happens, then two numbers, when you multiply, you get the c, and two numbers, the same numbers, when you add, you get b. So all the ways that I can get a 6, that when I multiply get 6, but add to get a negative 5. So one of the ways is to find the factors of 6. Start simple. 1, 6, 2, and 3. Remember, positive, I can also have negative 1, negative 6, negative 2, negative 3. So here are all the possibilities of 6. Which one of these, when I add, will give me the b? In this case, b is negative 5. So here it is. Negative 2 plus negative 3 gives me the negative 5. So this is, you're always going to get an x and an x, so we can get to x squared, and the answers are negative 2 and negative 3. So negative 2 and negative 3. And this can be repeated as many times. Let me do one that has a positive here and a negative there. So let's do x squared minus, you know what, let's do minus x minus 20. It wouldn't matter. It really doesn't matter. Again, it's the same process. Two numbers you multiply give you negative 20, but add gives you that negative 1. So if I go to the side for negative 20, 1 and negative 20, or negative 1 and 20, 2 and negative 10, or 2 and negative 10, 3 doesn't go, 4, 4 and negative 5, or negative 4 and 5, and I think those are all the factors of 20. Which one, when I add, gives me a negative 1? So the one that gives me a negative 1 is the 4 and negative 5. So this factors into, here's your xx, and you got a positive 4 and a negative 5. Okay? So that's the main idea when a is 1. Alright? The next one is when a doesn't equal to 1. Alright, so if a does not equal to 1, so let me think of a problem. So let's do 6x squared minus x minus 2. Okay. As you see, a is not 1. We are going to do what's called the borrow and payback method. We're going to borrow a, and then we're going to pay it back. Alright, borrow the a and pay it back. So here we go. We're going to take this a and we're going to borrow it, and you're going to multiply. Borrowing the a means take a times your c. Hence, some teachers call this the AC method. So if I borrow this a, I get x squared minus x minus 12. Because 6 times that negative 2. Now this problem is the same as what we did up here. Now it becomes a to be 1. That's the whole idea why we took out the a, so that we can get to this stage right here. So all the possible ways to get negative 12 to add to give me a negative 1. So that is going to give me an x and an x and a negative 4 and a positive 3. Now we are going to pay it back. So how are we going to pay it back? To pay it back, you divide each of these numbers by the number that you took. Pay back by dividing. So this becomes x minus 4 over 6, and then x plus 3 over 6. Now, if you can reduce these first, then reduce them. Now, if they are reduced and they become nice numbers, fine. But like just in case if I had like a 6 over 3, if I reduce 6 over 3, that becomes a 2. So we have to reduce. So this becomes x minus 2/3. This becomes x plus 1/2. As you see, after I reduced, there was no nice numbers. Okay. If there's no nice numbers, then you're going to take whatever's in the denominator and pull it up front. So take denominator, put it in front. That's if you don't have nice numbers. So this becomes 3 goes over here, so that's 3x minus 2. The 2 goes over here, so that's 2x plus 1. And hence you just factored when a is not 1. So when a is not 1, we are going to borrow. That's by multiplying. We're going to factor as we did normally. And then we're going to pay it back right here. At this stage, you have to reduce. And reduce means like you can do the division. If it's a nice number, you keep it. If this was 6/3, this becomes x plus 2. And we're done with that. Okay? The only time you bring this up front, if you have these fractions, after you reduce, you take that denominator and you just put it in front. And we are done. Alright. The next one is the GCF, the greatest common factor. In the GCF, first you attack, do they have a number in common? And second, you attack variables. Do they have the same variable? We don't care about the power, but do they have the same variable? And they all have to have the same variable. If 2 out of 3 don't, then too bad. So, for instance, if we start with like 2x minus 14, I can see here between 2 and 14 have a 2 in common, so I can factor out that 2. 2 divided by 2 is 1, and I still have an x, so it's 1x. Negative 14 divided by 2 is negative 7, and hence that's factored into that. Okay? Let's do 3x squared plus 15x. Well, I can first attack the numbers. Between 3 and 15, yes, that has a 3 in common. This has an x, this has an x. So to factor out, to find the GCF of the variables, you always take the lowest power. The lowest power on variables. Okay? So, the lowest power between 2 and 1 is 1, so that takes an x. Open our parentheses. Do your division. 3 divided by 3 is 1. I had 2 x's, but I took 1 out. That leaves me with 1x. A positive 15 divided by 3 is a positive 5. I had an x, and I took an x out. There's no more x's, and we are done. Now, sometimes we get more creative with this. Let's do a 6x squared y z cubed plus 24xy squared z squared minus 18 x to the 4th y z. Again, I'm just making this stuff up. So first I attack numbers. 6, 24, and 18. Do they all have a number in common? And the answer to that is yes. That is a 6. This has an x, this has an x, this has an x. So I can take out an x. Now let's do the power. This is squared, this is 1, this is 4, so the least is 1. So I'm just take out an x. This has a y, this is a y, this is a y, so we can take out a y. Now let's check the powers. 1, 2, and 1, so the lowest is 1. Z, z, z. So I can take out a z. Now let's check the powers. 3, 2, 1, the least is a 1. So these three things have a 6, x, y, z in common. So now let's do the division. 6 divided by 6 is 1. I had 2 x's, took 1 out, that leaves me with 1x. I had a y, took a y out, no more y's. I had 3 z's, took out 1 z, now I have 2 z's. Positive 24 divided by 6 is 4. I had 1x, took 1x out, we're gone. I had 2 y's, took 1 out, I get 1 y left. 2 z's, took out 1 z, I have a z left. Negative 18 divided by 6 is a negative 3. I had 4 x's, took out 1 x, so that gives me x to the third. I had a y, took out a y, that's gone. I had a z, took out a z, that is gone. So we are done. And that's all there is to the GCF. Number and then variable. They must all have the same variable, and you always take the lowest power in the variable. But from now on, anything that we are going to factor, we must try the GCF first. Okay? You must try it first from now on. I know I showed when A is 1 and when A is not 1, but like here, 1, negative 5, and 6 didn't have anything in common. 6, 1, and 2 did not have anything in common, so that's why we just went through it. But sometimes you might have something in here that you can take out, like this, you know, and then we can factor further. So GCF was the next one, and that just says go if they have a number in common, and if they have a variable in common, but they must all have that variable, and if they do that, get the lowest power. Alright, next is grouping. Alright, grouping acts just like the word says, to combine things. So grouping works when you have more than 3 terms, when you have like 4 or 5 or 6 or whatever. So this works when you have 4 terms. Basically, we're going to talk about 4 terms. And 99% of the time, you are going to group the first 2, and then group the last 2. And once you do group the first 2, then you're going to do the GCF. And when you group the last 2, then you're going to do the GCF. Okay? So, for grouping, so let's do 6x plus, let's do 18 plus, let's do 18x squared plus let's do 21x. I should have picked ones from what I did. I'm just trying to group like these 2 together, and I'm going to group those 2 together. Let me just make one up for the heck of it. Plus 63x squared. I know this is not what I meant to do, but just to show you, if you had something like this, you group the first 2, then you group the last 2. So these 2 have a 6 and an x in common, and then we have 6 divided by 6 is 1. We took out the x, so we have that 1. 18 divided by 6 is 3. I had 2 x's, take out 1, so I get 1x. 21 and 63 have a 21x in common. 21 divided by 21 is 1. We had an x, took out an x, so that's a 1. 63 divided by 21 is 3. I had 2 x's, took out an x, I get an x. So my whole thing is that we have one thing and another thing, and as you see, they still have this as a GCF. I mean, why? Because GCF is what they have in common. This number here has this, and this number has this. Those are the same thing. So we're going to take that out. Take out the 1 plus 3x from this left side, you're left with 6x. Take out 1 plus 3x on the right side, you get plus 21x. And that's the idea for grouping. Okay? So grouping, you group the first two, you group the last two, find the GCF, and more than likely whatever's left in these parentheses, our goal is to get these to be the same. Sometimes we talked in class that you might want to take out a negative or a positive here. It does happen that if we wanted this to be a negative to make these two look the same, we just change these signs, and ultimately we're going to come back down to this. That is grouping. Okay? Chunking was next. Chunking means to rewrite the first two terms. Such that they have something in common. Excuse me. Alright, so let's show you what that means. Alright, so let me make an example here really quick. Okay. And let's do that. Or let's do, hold on, I'm trying to think of a nice one right here. There we go, found one. So let's do 9x squared plus 12x minus 12. So I want to rewrite the first two, okay? The trick behind this is, how can I rewrite this as something squared? So 9x squared, 9 is easy, which is 3, and then to get x squared, take 2 divided by 2, that's 1, so that's got to be x to the first power. Next, we are going to reuse this 3x. What times 3x gives me this 12x, and that's a positive 4. And then I'm going to bring down that minus 12. As you see, I only played with the first two, and I rewrote them such that they have something in common. That's what we mean. So whatever that they have in common, I'm going to substitute that. So in class, I said let z, and again, you can choose any variable that you wish. Let z be that 3x. So now if I substitute it here, I get z squared plus 4 times z minus 12. And now that looks like when a is 1. So when I multiply, gives me a negative 12. When I add, gives me a positive 4. And that is a positive 6 and a negative 2. But we know what z is. Z is 3x. So this is 3x plus 6 and 3x minus 2. So this is chunking. To rewrite, I mean, don't get me wrong, I can take a look at this and say, oh, I could have did 9 times this negative 12, give me that negative 108, and then do it when a is 1. It's a different process, but at the end, I'll end up with this. So in order to get away from the borrow and pay back, one of the ways is to notice that these two have something in common. Okay, and to figure that out, you always take the first one and rewrite it as something squared. Okay, and then we make our substitution, and then we go when a is 1, and then substitute back in. So that is chunking. Next is the difference of two squares. Now I know I did more examples in class. This is just a review on how to do these. The difference of two squares, from its word, it says the difference of something squared minus something squared. And this has a formula. which means if we can write something as something squared minus something squared, then that's the same thing as saying a plus that something and then a minus that something. The giveaway here is this: in this problem I only have two things. I have a minus sign and we have squareds. So I have to pay attention to that. So let's start simple. Let's start with x squared minus 4. So the question becomes, can I rewrite this as something squared minus something squared? This is how we kind of set it up. So what can I put in here to get this x squared? Well, 2 divided by 2 is 1, so that's x to the first. That still gives me x squared. What number times itself gives me 4? That is 2. So this acts like my a, this acts like my b. So this, we're going to follow that formula. So it's going to be a plus b, so it's be x plus 2. And then a minus b be x minus 2. And we are done. Okay. Now sometimes we might end up with something like this. Still, I look at them like, oh look, there's a minus, two things, and I have a squared. So let me try something squared minus something squared. This 9x squared, let's talk about the number. 9 would be 3, and then x squared would be the x, and as you see, 3 to the second is 9, x squared, you get 9x squared. This 16 is a 4, because 4 squared is 16. So that acts like my a, that acts like my b, so I'm going to end up with a plus b, the 3x plus 4, and then the 3x minus 4. And so, remember what I said, sometimes we have to do the GCF, okay? Sometimes we have to do that. So if I have this problem, 3x to the third minus 75x, you might say, hey, I still got two things, I got a subtraction, but I don't see squared. But the two things and a subtraction just jogs my memory. It could be a squared minus b squared. So the first thing I'm going to check is, does this have a common factor? So let's look at the numbers. Between 3 and 75, it's 3. This has an x, this has an x. The lowest power is 1, so it'll be 3x. Do our division now. 3 divided by 3 is 1. I had 3 x's, took 1 out, I get x squared. Negative 75 divided by 3 is negative 25. Had an x, took out an x, I'm done. This part right here now looks like something squared minus something squared. So here we go. Can I write it in this fashion? Well, the x squared is simple. The 25 is simple. So that looks like my a, that looks like my b. So we have 3x, this stays where it is. A plus b, so it's x plus 5. A minus b, so it's x minus 5. So this is the difference of two squares. You have to pay attention first, the giveaways, two things, and the minus sign. So that's, it could be this. So we check GCF first, like there's no GCF here, no GCF, and see if we can rewrite it. Okay? The next one is the perfect square trinomials. Perfect square trinomials. And there are two of them here. And these are a little bit different. These say if you have something plus something and it's the whole thing squared, there's a difference. This has a formula. It says square the first one, then multiply the first times the second, and then you're going to double it. So 2ab, see, first, second, double it, and then square the second one. Okay? So, in this case, We usually tend to go either forwards or backwards. I'm going to start going backwards, giving you something like this to see if it can be done in this fashion. Okay, so let's start something like very simple. So let's start with, let's say, x squared plus 8x plus 16. Now, I know I can do this while a is 1. Okay? But give me a minute. We'll show you one that might work in your favor. I know we can do that. But here, I can test this out. And to test it out is you test the first one, say, how can I rewrite it as something squared? Because that's what a squared is. And then test the b out. This 16 is what? 4 squared. Now I'm going to test the 2ab. So I got 2 times the a, which is x, times the b, which is 4. Does this give me this 8x? Well, 2 times x times 4 is 8x, so that works out. So that means a is x and b is 4, so this becomes x plus 4 quantity squared. Okay? So now let's do another one. So let's try this one. 8x squared plus 24x plus 18. Alright. You might say, hey, I can do this borrow and payback. 8 times 18. Okay. So that would be, what, 144? And then to get all the numbers to get to 144 to add to 24, I'm not going to sit there and waste my time. So I'm going to try if that fits this idea. But before I do that, I can't do 8 squared, can I? A number times it'll give me 8. So I remember what we said, try the GCF first. Does 8, 24, and 18 have a number in common? The answer to that is yes, they all have a 2 in common. Okay, so that leaves me with a 4x squared plus 12x plus the 9. Okay, so now we think about this. I still can do the borrow payback. Now it's up to 36, but I don't want to sit there. So here, 4x squared, I can write it as 2x quantity squared. I'm focusing on just the inside. The 9 is 3 squared. Now I'm going to try 2 times 2x times 3. Does that give me the 12x? 4 times 3 is 12x. Yes, it does. So this right here, the 2 stays on the outside. This right there is 2x plus 3 quantity squared. And now the other way around. We went from here to here, now let's go from here to there. And this is simple. Let's do a 4x plus 6 quantity squared. This is saying, remember I did this in class and I was doing them in my head? So all you do is you square the first one, so 4x squared, so that gives me 4 times 4, that's 16x squared. Then multiply this times this, and then we're going to double it. 4 times 6 is 24, double it is 48, don't forget that x, so this is 48x. And now we're going to square the second term, 6 squared is 36. So this squared is this number. I know in the past we rewrote it twice, and then we distributed, then we combined like terms, and then we should end up with this. But now we know that there is a quicker method, which is a perfect square trinomial. Something plus something, the whole thing squared. Square the first, multiply them, and double it. You get that middle term. And then square the second. Okay? So real quickly, if I have a 3x plus 2 quantity squared, square that, so that's 9x squared. 3 times 2 is 6, double it is 12. Square the 2 is 4. All you have to do is practice. The other one that goes with the perfect square is I'm still under perfect square trinomial, but instead of a plus b, now becomes a minus b squared, and that becomes a squared minus 2ab plus b squared. And if you really look at these two, they're similar. Plus is plus, minus is minus. Nothing is different here. Okay? So let's do a problem. Let's see if 16x squared minus 16x plus 4. Okay? Let's see if that is in our favor. Again, if you want to do the AC method or borrow payback, I'm not doing that. This is 4x squared. 4 is 2. I'm going to check. I'm going to check now negative 2 times 4x times 2 because that's a negative there. 2 times 4 is 8 times 2 is 16x. Yes, that works out. So this is 4x minus 2 quantity squared. Okay. So that's perfect square trinomials. The next that I have is sum of cubes. So that says something cubed, let me call this a, sorry. Let me call this a cubed plus b cubed. That's the sum of cubes. This has a formula, a plus b. Then you square the first. Then you multiply them, but it's going to be a subtraction. And then you square the second. Okay? So a cubed, something cubed plus something cubed can be written as those two somethings, square the first, multiply them, but it's going to be a minus, then square the second. What I said in class today, if it's a plus, you're going to start out with a plus, then it becomes a minus. So if it's a plus, plus minus. Easy thing to look at is x cubed plus 8. How can I rewrite this as something cubed plus something cubed? Well, the x is easy. 3 divided by 3 is 1, so x to the first. What number times itself 3 times gives you 8, and that is 2. So that's my a, that's my b. So this becomes, I'm following the formula. X plus 2. Then a squared minus a times b plus b squared. Again, like I said today in class, I'm just doing this for your visual purposes. We should start looking at, if I have this x and 2, we should be doing these in our heads. But if you need to write them, write them. This becomes x squared, negative 2x here. When I multiply x times 2, there's a negative, and 2 squared is 4. Okay? And again, we should have checked GCF. This one does not have a GCF. Okay? But if it does have a GCF, then you just take out the GCF, and then you go through this motion one more time. That is the sum of cubes. Nothing's different. It's the same. Let's do the next one, which is related to this, and that is difference of cubes. Again, if I had a GCF, you take out that GCF, and then you say, whatever's left, can I rewrite it as something cubed plus something cubed? Okay? Difference of cubes is the same thing, except now it's a minus sign. So this gives me a minus b, and then a squared plus ab plus b squared. So this is the opposite of that. Plus was plus minus. Minus, we start off with minus, then plus. Okay? Same idea, same everything. Okay? But now we follow this format. So if I had a 27x cubed minus 64y cubed, Okay? So let's see if I can rewrite this as something cubed. I see a minus. Something cubed. Take the number 27. What number times itself 3 times gives you 27? That's 3. X cubed, 3 divided by 3 is 1, so that's a 3x. So 3 to the third is 27, then x 1 times 3 is 3. 64 would be a 4, and then y. So a is 3x and b is 4y. So I'm going to follow the format. A minus b. A squared plus a times b plus b squared. So now we got to do the math on the inside. 3x minus 4y. 3x squared, so 3 squared is 9. 1 times 2 is 2, so x squared. 3 times 4 is 12, times xy is 12xy. Remember, if they're different variables, just attach them. 4 squared is 16, and then get y to the second power. Oh, doesn't matter, brackets or parentheses. Alright, so that gives me the difference of cubes. And then finally, the last one is quad form. I'm hearing some of you texting me right now, but I'll answer you guys in a second. Quad form only works in one scenario, and that is if you have to the 4th power and then to the 2nd power. Okay? So let me make up an example. X to the 4th minus 6x squared plus 5. Yes, we see 4 and 2. It doesn't matter the sign in the middle here. The easy way, what I showed you today, is since it's 4 and 2, it will always be x squared and x squared. Always, always, always. Two numbers when you multiply gives you 5. Add to gives you a negative 6. And that's a negative 1 and a negative 5. Okay? But now we're not done. Now we have to say, hey, this catches my eye real quickly. Why? Because I have two things. I have a minus sign. That means I might rewrite this as something squared minus something squared to look like the difference of two squares. This one, almost in the same boat, but the 5, I can't rewrite it as something squared. So the only one that I can rewrite here is this one as x squared minus 1 squared. And now that looks like the difference of two squares. So I have x plus 1, x minus 1, and then I have x squared minus 5, which I can't do nothing with. Alright, so here are the 11 different ways of factoring in a nutshell. Just work at it.